Okay, Assalamualaikum warahmatullahi wabarakatuh. Right, kita continue the effect of data changes in dispersion. Right. Okay, let's check it out. Right, so kita akan tengok the effect the data changes include, okay, kita tengok the following cases, which is dia boleh, effect of data ni boleh change on dispersion. Okay, so tengok the first case is each data is added or subtracted by constant uniformly. Constant ni is a kind of number ke, macam 2, 7, okay. Right, uniformly. So uniformly maksudnya kalau kita ada 5 data, 2, 4, 7, 3, kalau semua added by 2, so ni pun kena plus 2, plus 2, plus 2, plus 2. Uniformly, semua akan dapat. Right? Okay, and then tadi added or subtract. Next one is multiplied or divided by constant juga, same thing, uniformly. Okay, alright, so next is the existence of outliers or extreme values, okay, in the set of data. Extreme values in the set of data, right? So next, a certain value removed from the set of data or added into the set of data. Ada certain value yang sama ada kita add or kita remove. Okay, tak semestinya dia outlier pun, tapi certain value that we added or we remove from the set of data. Okay, alright, ini kita nak tengok. So we're going to determine the effect of data changes on dispersion based on value measure of dispersion or graphical representation. Right, so jom kita tengok. Okay, now this one add or subtract, so added value or subtract. Okay, kita tengok this case. Initially I have a set of data 5, 8, 3, 8, 3, 4, 1. Okay, right, if each of the value set of data is added by 5. Okay, so tengok added by 5, each value added by 5, then the data above will be, okay, so when each value 5 plus by 5 plus 5, see, dapat 10, 8 plus 5, 13, 3 plus 5, so dapat 8, and so on lah. So semua ni akan plus dengan 5, then you will get this one. Okay, then kita akan tengok what will happen to the measure of dispersion. Measure of dispersion yang kita ada, which is such as range, the quarter range, variance and standard deviation. Okay, right, kita tengok this example, which is in the graphical. So kita tengok dalam graph. Okay, the data is changed uniformly by adding or subtracting a constant. Okay, so now this is the original one. Okay, look at this one. This is the original. Kita ada 8 until 15. Okay, so this is the data, the dot plot. So this is the data. Kita ada ini is a frequency, how many person ke, how many people yang dapat pupils yang dapat score in science quiz. Ada score 8, ada 1, score 9, ada 3 and so on. Okay, this is the data. Now when each of value, so this is the value, okay, value yang kita ada, each of the value of set of data is added by 2. Added by 2. Okay, each value tau added by 2, which means 8 plus 2, see, akan jadi 10. So this one pergi dekat 10. Yang 1 person tadi, 1 people tadi pergi dekat 10. Okay, 9 plus 2 will be 11. So it become here 10 plus 2 is a 12. Okay, and dia akan pergi. So based on these two, this is original, this is new one. Okay, right, in the above diagram, when each of the value of set of data added by 2, so we can found that okay, kita tengok the whole diagram, okay, is shifted, kan, is shifted to the right 2 units. Okay, tengok daripada 8 daripada sini, so dia dah pergi ke sini, nampak? Situ shifted 2 unit to the right. Okay, alright, itu dari segi apa ni, the movement dia punya data. But if you can see clearly, the dispersion is still remain the same. Sebab dispersion ni kita tengok the gap kan. Kita tengok kat sini. Dia disperse sama je, cuma dia shift ke kanan. Right to the left, two to the right, shifted two to the right. Okay, alright. If nak tengok daripada dispersion, so kalau kita tengok roughly memang sama lah. Now kita try kira, kita calculate. Okay, kita tengok the original score range. This is original one. Okay, so this is the original. Okay, now kita tengok score range. Kita ambil largest value 15 minus dengan 8. Okay, large minus dengan smallest. So kita ada 15 minus dengan 8. So you will get 15 minus 8 dapat berapa? 15 minus 8 dapat 7. Okay, new score range. So new score adalah dekat here is 17 minus dengan 17 minus 10. 17 minus 10. Then you will get 7. Okay, means that okay, we nampak kan? So therefore bila kita daripada added or subtract value, we can see here the range of both set of data is the same. The range is the same, dia tak ada tukar apa-apa. So in general we can say that when each value a set of data is added by a constant tadi mana? 2. This is constant. Okay, this is constant 2. Okay, right, the measure of dispersion remain unchanged. Okay, the measure of dispersion remained unchanged. Tak, kita nampak. Okay, because kat sini kita dah nampak range of both set of data are the same. So we can see here. Ni apa benda? So we can see here, nampak range both of them are same. Okay, so therefore, okay, this is the conclusion kita boleh buat. Therefore, bila kita added or subtract value from the original data, okay, tapi each value kita kena add or subtract each value by constant okay, so therefore there are no changes. Kita pakai no changes to the measure of dispersion. Okay, so when each of the value of set of data is added or subtracted by constant. Okay, right. Okay, so itu untuk add and subtract. Now kita move to the multiplication or division. So kita nak multiply or divide. Okay, kita tengok this case. Consider this case. Initially I have a set of data, so this is the set of data. Each of the value of the set of data is multiplied by 2. Okay, now it's multiplied by 2. Each value multiplied by 2 pula. So bila dah multiplied by 2 uniformly, it will change lah. 5 times 2, so dapat 10. 8 times 2, dapat 16. 3 times 2, so dapat 6, and so on. Okay, alright. Now again, kita nak tengok what will happen to the measure of dispersion such as range, interquartile range, variance and standard deviation. Right, so let's check it out. Kita tengok contoh ni. Okay, the data is changed by multiplying or dividing or by a constant. Okay, now kita tengok. This is the original one. This is the original one. Okay, when each value of set of data is multiplied by 2. Multiplied by, terpotong lah. Okay. So multiplied by 2. Okay. Now this is value yang kita ada. These are those value yang kita ada. So ni times 2 not jadi 2. So dia punya number of people pun dah pergi dekat 2 lah, dekat data yang baru. Okay, so 2 times 2 it becomes 4. So dia dah shift sini dah pergi 4. Okay, 3 times 2 6. You see? Okay, so this one pun dah di sini and seterusnya lah. Okay, so from here in the above diagram, tengok when the set of value of when each value of set of data is multiplied by 2, so what we can find that the whole plot, okay, the whole plot it become wider, right? Tapi twice, so become wider twice. Kat sini kita nampak, okay, sebab kita tengok kat sini dah jadi, nampak dia ada gap, become wider. Tadi dia dah kat sini je, so dia dah disperse more, okay, become wider but twice. So kita try in terms of calculation. So kita tengok original score, look at the original graph is range is largest value minus dengan smallest value, which is kita ada 8 minus 1, 8 pula. Pula sampai 8 kita ambil kat sini je, sampai dia punya data paling besar is a 5. 5 minus 1, sorry so 5, sikit lagi nampak, okay, jap. 5 minus 1, so equals to 4. Okay, new score range, okay, 5 minus 4, ini 10 minus 2, okay, so 10 minus 2, dapat 8, right? Okay, from here we can see, kalau tadi korang nampak dia punya disperse is a twice, kat sini kan kita nampak twice, dia wider twice, wider, okay, dia wide twice. Kalau yang tadi it remain the same, tak tukar langsung, because dia just shift je, dia tak tukar pun dia punya dispersion. The disperse tu is still the same, but this one dia disperse become wider, so disperse more kan, it disperse more, and dia beritahu kita nampak pula it disperse twice so why don't you look at it, look at here. So 4, kalau lah kita darabkan 2, because this is twice twice, so times 2 dapat tak 8, dapat kan? Okay, so kat sini kita boleh nampak satu yang kita boleh cakap, tengok range become larger kan, so the range of data is larger. So kita tengok kat sini,
siapa yang ambil Pfizer dah sudah
range
sebelum 8 ambil ini AstraZeneca ni, dia ni lab dia lama,
dia become larger kan.
dia ni dekat
Okay, larger tu sebanyak berapa? Okay,
dia gap ni 3 bulan dia buang.
tak larger
Dia cepat. Kalau yang sini
okay,
mungkin
so
lagi
kat
cepat.
sini
Sinovac tu lagi cepat.
tak ada larger lah, so kita boleh nampak dia depends on berapa kita multiply. So actually the range of new set of data ni 12 times. Okay, tengok kita ada kita cuba macam ni je lah. New range is equivalent to tengok sebab K tu kita punya constant kan, you can see that dia berapa kali ganda tu is based on constant, so it multiplied by 2, so K times dengan ini lagi senang nampak, original range. Sebab dia become larger tu bukan sebanyak larger macam biasa-biasa je, it depends on berapa kita punya constant. If you multiply by 5, so 5 times dengan original range. You multiply by 2 times dengan original range. Okay, so when each of the value of set of data is multiplied, so when each of value of set of data is multiplied by constant K, nampak constant K, the measure the dispersion will change. So how it change? Okay, look at here. Macam mana dia change tu? Okay, this is the conclusion. Kita boleh tengok kat sini. When each of the set of value of data is multiplied by a constant K, okay, right? So new range K times original, macam tadi lah. K darab dengan original. Lepas tu kalau interquartile pun okay, new range K darab dengan original range. Okay, interquartile range K darab dengan original interquartile range. New standard deviation, K is a constant darab dengan dengan original standard deviation. Yang beza variance. Jangan tertukar tau. Walaupun kita punya susunan selalu kita letak range dulu, interquartile range. Kita cari variance kan. Variance kan yang ada power of 2 kan. So ini deviation kan. So yang ada power of 2 tu, constant dia pun akan power of 2 times dengan original variance. Okay. Alright. Okay, now teacher highlight sikit lah kat sini. Jadi untuk variance dia special sikit sebab kita pakai K squared. Same thing goes to division. So bila kita buat divide, kita each value set of data divided by a constant K. So nak cari kita nak cari new variance, new interquartile range, new standard deviation. All of them kena divide by constant K. Kecuali accept new variance. So new variance kita divide juga tapi by K squared. Okay. Ini conclusion yang kita boleh buat. Alright. Okay. So kita tengok lagi satu case. Kita ada 3 tadi. Ada ni ni teacher kita akan tengok dua-dua ni. Existence of outlier dengan remove or edit. Okay. Okay. Oh, sekejap kita try dulu. Kita try this one dulu. Okay, so kita tengok dulu lah yang multiplication and subtraction. Okay. The range of the variance of set of data are 25 and 2.7. Okay, so 25 and 2.7 respectively. If each value of data is added by 2, ni dia bagi each value added by 2 then multiplied by 4. Okay, determine the new range of the new range and the new variance. Be careful. New range and new variance. Okay, right. So kita ada okay. Now apa information yang dia bagi kita? Range. Original lah kan? Sekejap the original range is given. So range ada 25 variance 2.7. Okay, so this is the original lah. Okay, so ni original yang kita ada. Now kita nak then added by 2. Okay, added 2. Right, bila added 2, so ingat balik. Bila add, there are no changes to the measure of dispersion if a set of data is added or subtract by a constant. So even though kita ada range ke, variance ke, standard deviation ke, interquartile range ke, added, there's nothing will affect. Okay, no changes. Therefore, bila no changes, new range still 25. Okay, new variance still 2.7. Okay, alright. So now kita try untuk multiply. Alright, so kita try multiply new range. Okay, multiply tadi macam mana? Okay, so this is multiplication. So bila multiplication, new range K constant akan darab dengan original range. variance, must be very careful. So kita tengok basis, standard deviation and variance. So kita dekat variance, so variance mesti K squared darab dengan original. Okay, therefore kat sini, okay, kita akan dapat new range. Okay, dia kata kita add by 2 dulu, lepas tu baru multiply by 4. Tapi sebab kita add by 2, so no changes. Okay, guna je lah ni, nak pergi kat sini. Alright, so bila ni pergi ke sini, kena tengoklah yang ini K times dengan original range. So K kita 4 darab dengan 25 dapat 100. Okay, alright, so look at the next one. New variance. K squared darab dengan variance. So 4 squared darab dengan 2.7. Sama. Nampak? Okay, sebab tadi ni dah kita pergi kat sini, no changes. Okay, ni pergi kat sini, kita kena darab dengan constant ya. Kat sini. Right. So therefore, kita akan dapat 4.16 kan, darab dengan 2.7. So dapat 43.2. Sekejap.